Right, hopefully that is now working. I'm not entirely sure. Don't know if you can send me like a little thing on the side. In fact, I just don't know. Like on the Q&A, is the Q&A open? Is that a thing? It's changed a little bit since we did it for lockdown learning. We've changed a few things on here. Ah, there we go. Thanks, Duncan. Perfect. Give like people a couple of just a minute just to see if there's anything else. Anyone else that's like struggling or whatever. It's a bit weird. Just feel like I'm speaking to myself, but that's absolutely fine. It's completely normal. There we go. Yeah, working. Fab. Right. Well, it's now 32 minutes past. So even if people jump in late, it's not an issue at all. But for those of you who haven't met me, it's a bit weird because obviously in year 6, parents don't really come around as much, so I don't actually get to meet you, which I'm a bit gutted about, to be honest, because it's always nice to meet the parents and actually meet where these lovely children have come from. Just wanted to do this in person really, but obviously not allowed to do that, so here we are on a weird live event. And just introduce myself and then go through just essentially some mathematical methods, because one of the things that I found last year was that what we were teaching in school and what children then did when they went home and with homework and things like that just led to confusion within their mathematical learning and conceptualization of things. This isn't supposed to be condescending or patronizing in any way. I'm not, going to tell you how to suck eggs or whatever. Just hopefully so that it's helpful, so that there's the consistency between school and home. We're all singing off the same hymn sheet, basically. To go back to the start, I'm Greg. I've probably emailed a few of you. I've maybe seen a few of you outside, or even in one case, I think, taught a child last year as well. I did actually teach your children, when was it? It was a couple of years ago when I started here doing PPA, and Miss Gardner got moved and I was then put in their class. Just excited, second year, still very much spring chicken, but absolutely loving it. And had a good year last year, but we were hampered still by COVID. So I've just got my fingers crossed that doesn't happen again, because nobody needs that. I think everyone would very much agree as well. So yeah, and I'm not someone to try and close off parents. If you need anything at all from me, if you want me to send any more maths work home or anything, if you just generally asking about what they're like socially in school or anything like that, please do. Come up to the door, send me an email, chuck me a text. I think communication is everything, and if that fails, then you got no chance. So I don't want this to take loads of time out of your day either. I really appreciate the fact that you have jumped on as well. So what I'll do is I'll share my screen and just go through the methods, hopefully quite quickly, of how we use them in Llysfaen Primary. It does still vary from class to class. I'm not saying that it's like really consistent all the way through, but it's just giving children the opportunity, I think, to find what suits them as well. there's no point in forcing them to try and get something that they clearly don't understand. So finding a method that suits them is just as important as, you know, teaching one of them. Just for some extra context as well, this is, I mentioned in the letter, I had to write this huge letter that was probably a little bit more confusing than it needed to be honest. As it's for my master's, so obviously ethically, everything has to be ticked off properly, and all of it had to be signed off by my own tutor. But a couple of weeks after this, I'll give 2 sets of homework out on the Fridays, and they will both be maths based, maths and numeracy. From there, then it'll just be a case of, I think probably a week after that, then I will send out a questionnaire and just see as to whether any of these have actually helped at all, in terms of you engaging and anything else with your child's learning. So this evening, or probably tomorrow now, because I think Mr. Jones is going to go, I will put the videos onto the website. I'll let you know where they are, and also the PowerPoint that I made as well, that just explain the workings again, the methods, but they're just there in a different format for you to access if you need to. Right, let's go for it. I will sort of be standing up next to the board. It's almost like teaching, but to myself, which is a bit of a weird one. But yeah, if you do have any questions, I will try and come back and check the chat as well. But just let me know, basically. So that should still be, is that on the screen? Have I just got column addition written on the board? Is that? I think there's like a 30-second delay as well, I said. So the actual chat's an interesting one. Shall I just crack on? So hopefully you can see column addition on the board, and what I want to do is literally just whiz through them. So first one there, I'm not trying to be condescending, I'm not trying to be patronising, literally just rattling through them to give you a flavour, and then you can go back and have a look at them, and so that if your child does need help when they're doing their homework, then we're both saying the same thing, if that makes sense, just that consistency from school and home. So always the most important thing with column addition and any columns is that the numbers are in their correct columns. So we've got our ones and our tens, and then goes on to hundreds and thousands further on. And here we've got a decimal point over here. So that one there, we go into our tenths then as we go past the decimal point. So always starting from the right hand side. Okay, so this side here, and we're going to do 7 and 4. So we're going to put our 1 down there, and we need to carry the other one because it's 11. I prefer when I'm carrying them to have them underneath here, because otherwise what happens is they put a 1 up there and then it looks like a 12 and it becomes confusing rather than actually adding them on. So trying to keep the 1 underneath the line. So you've got 8 add 2, sorry, put my 1 back there, 8 add 2, and also add in this one as well. Important for them not to forget that. So then we've got 11. Am I going mad? Yeah. Okay. Next one. So going over then, I've just written another one down. It's the decimal point. So this is where I just wanted to show how the importance of actually lining up our digits correctly. So we've got 31.2 and 89. Now, we even did this earlier where somebody lined them up incorrectly, and it's just really easy to do. So obviously, this 89 there is essentially the same as 89.0. So we can put that in if we want, just to make life easier for us. So 2 add 0 then is just 2. We put our decimal point in. 1 add 9 is 10. So we put the 0 in, and we carry the 1. 3 add 8. So we've then got 11 but plus the 1 as well, so we've got 12, so we've got 120.2. Okay, so addition, we did it today and everyone was pretty happy with it. It's just sometimes the lining up of digits, especially when there are decimal points in the questions. Quickly go on to column subtraction. If I just look at the chat quickly, I seem to have opened Spotify instead. That's helpful. That's not the one. Oh, right. Not showing the board. Right. If I stop sharing. Is that working now? It's always going to happen, isn't it? Can't see the board, can't see the board. Looking at my camera. So you've seen me standing, which is great. Can we see that now? Has it changed at all? No, still no. Right. It says presenting, but you guys still can't see that, can you? No. Ooh. How about that? Is that there now? That could be a thing. Always the technical hitches. Yes, there we go. Good. Right, if I actually start writing, that might be a different case, but we'll see what happens. Okay, if I just go back quickly, is that changed on here? Ah, it's changed on there as well. Love it. Okay, so going back quickly, just the column addition. If I just sort of run through it, so like I said, you might have heard me say it, but not actually seen it. Lining up the decimals, the digits is always really important. So got our 7 and our 4 in the same column because they are our 1s, the same for the 10s, and then our carrying. Okay, so just to highlight those numbers there, I put it there underneath the line because otherwise if I put it up there, it starts to look like a 12 instead. Okay, and that just ends up confusing people and it's not beneficial for anyone. Same again then over here, my original question was 31.2 and then adding on 89, so I didn't have that. Okay, and then in the question it looked like that. Now that's where it's easy just to think, oh actually right, so I should have my 8 and my 9 there, but obviously because the decimal point, if you were looking at that number, would be like that. We just need to make sure that we're lining up our digits correctly again. So put my 9.0. Okay, so putting the 0.0 into the question, even though it's not actually there, is sometimes beneficial just to actually round it off and make sure that we can see that our digits are going in the correct columns. And then same again, just showing that the number that I carried was sitting underneath the line rather than confusing me up here and making it look like 18. Whew. Right. Quickly onto column subtraction. Now I've just put a really nice simple one first, 84. Okay, but again it's just about lining up our digits. So we've got 4 take away 2, always starting from the right hand side, and 8 take away 2. So I've just got my answer there. Again then over here, a little bit tricky. Now this is where people tend to trip over themselves a little bit. In fact, I should check that this is still actually showing before I carry on. Start looking like a Muppet. let's do that most of the time anyway. There we go. So 101, pop it down, 101, and then we are subtracting 49. Okay, so still you can see lining up my digits in the correct columns. However, I'm looking at this now. I can do it, but I don't want to do it. Because if I did 1 take away 9, I'd end up with minus numbers, and I don't want to do that. I look over to my next column. Okay, so I need to gain some digits from somewhere now. However, in my next column there's a 0, so I can't take anything from there. So I've got to go over to my next one again. So I go into my hundreds now, and there's a 1 there. What I'm going to do is I'm going to get rid of that 1, so that changes to a 0. Some people call it borrowing, but I'm not actually giving it back, so it's technically like stealing. I think they've just called it borrowing to make it more school friendly. I'm not doing that. That'd be really silly. And then I'm going to carry that 1 over here to make this 10. However, I still need to make this number bigger over here. So what's going to happen is I'm going to, again, that's going, and that's going to change to a 9, because I'm borrowing 1 from there. Stealing, whatever you want to call it. And then popping it over here. So now I've got 11. Okay, and now that I've done that first part of my question, I can crack on with the rest of it. The rest of it's fine now. So I've got then 11, take away 9, which is 2. 9, take away 4 then, which is then 5. And there I have my answer. Okay, so it's just that little bit at the start of the question that trips people up. But once they've done that step and actually borrowed the numbers that are needed, from there it's absolutely fine. All of these as well will be, so I will put this live session on online, and as well as the other walkthrough videos as well. Grid multiplication. Now this was something that I never did in school, so it's not something that I was ever taught. It's relatively new, but just because it is a nice way of showing exactly what the children need to do. Some people love it, some people hate it, and they just don't get it at all. Now, in year 5, I know they used it a lot, and then they did 2-digit and 3-digit multiplied by only 1-digit numbers. But it's very much a preference. It's very much a preference. But the way to do it is at the top, this number here needs to be partitioned. Okay, so that means that so instead of 245, I'm going to have 240 and 5 in my boxes. And then this little dude here is going to go in there. So I've got in my grid now, I've got 4, 240 and 5. So first thing you need to do is multiply 4 by 200, and I'm going to work my way across. Now, sometimes when children look at 4 by 200, they just see a massive number and it's scary as and it's horrible. But all we can do is we just break it down so that we're doing 4 multiplied by 2. Just make it a little bit more manageable, and then we can put the number back together afterwards. So 4 multiplied by 2 is then 8. Okay, but we know that we need to keep it in our hundreds because it was just as big before. So make it 800. Same for this one if we need to. I'm hoping that by the end of the year, if we're looking at 4 by 40, we can crack on with that and we can do it. 4 by 4, 16. Okay, if we want to do it that way, and then we stick the 0 on as well. And then 4 times by 5 multiplied by 5 is 20. Now, that's not finished yet, though. So what we would then need to do is we go over onto the side and we need to add all of these numbers together. So what we're going to end up with then is a nice addition. So we're going to have 800, and then again, making sure that we line all of these up. 60, 20, and then just showing that we're doing addition. So in my first column, 0. On my next column, I've then got 6, add 2, and obviously my 0 there as well. And finally, 8 add 1. So my answer for that, so my answer for 245 times by 4 is 980. It can also be done if we're multiplying by two-digit numbers. So all we would do then is just extend our grid. So my grid would, I mean, obviously we might draw it a little bit bigger, but my grid would come down there like that. And I don't know, so I was doing 41, I'd just, it would then be 40 and 1. So you'd partition those numbers as well. Obviously these numbers would end up being different. Okay. On the video that I've done for this online, I have put an example of that as well, as to how that would be done. But I just didn't want this to be too long in terms of me just talking at you. So I realised that it kind of is what I'm doing. Again then, column multiplication, lining them up. So we got 41 and we're multiplying by 13. Start off by doing 3 times by 1. So that's going to be my first step here. So 3 multiplied by 1 is 3. And then my next step is going to be 4 multiplied by 3, which is then 12. And I'll write my 12 in there like that. Now, from here, because this number here is 10 times bigger than that one, my answer is going to be 10 times bigger as well. So for this, I need to start off with a 0 to show that. And then I can crack on with what I was doing before. So I can do 1 times 1, which is 1, and 1 times 4, which is 4. Then underneath, this is now an addition. So I need to show that I'm not doing a multiplication anymore. I've got 3 plus 0 is 3. 2 plus 1, 3, and 4 plus 1, which is then 5. So I've got my answer at the bottom just there. Now, the bit that just confuses people is that 0. We just do it for the sake of it. Or forget to put it in. If I was multiplying by a 3-digit number on the bottom, something like that, literally just for the sake of it. The first one, we wouldn't need to. The second one, that wouldn't work, would it? The second one, we would then have 1 0, and then our next one is 3 times bigger. So we need the 2 zeros before we started doing the multiplications that we would normally do. It's not overly confusing once the concept is grasped. At the start, it's just like, why? But once you get into it and get in a flow of doing them, then it does become a little bit easier. There is also, if I might show actually, the expanded method, where you write down everything that you are doing. So if I change that and did it yellow still, 21 times by 2, just to show you, nice and easy. I didn't even need a 3-digit number, but that's fine. So 4, 2, 1 times by 2. Now 2 times 1 is 2, and I write that answer there. 2 times 2 is then 4. Sorry, it's not right. 2. Go on. There we go. Okay, so these two here. So this is where you go back to the similar method then from your grid. So because this is now 2 times 20. So I'll just pop it in there. 2 times 2. And then the next one is 2 times 20. And then the next one would be 2 times 400. Okay, and then you can just write it out. So it's sort of like an in-between between our column multiplication and our grid multiplication. It introduces children to the the structure of column multiplication, but still using the partitioning almost of grid. 40 there, and then 2 times 400, 600, and then we just add them up at the end. Definitely not going there. But yeah, so that's like I say, I've done that in the videos online, but it's just there as a sort of like that in between method between column multiplication and grid multiplication. Right. Are there like any questions so far or anything like that? I feel I am rattling through it, but I'm just wary of time really. I don't want to take up your whole evening just to speak maths. We'll go on to bus stop division and everyone's most hated long division as well. And I think I put multiplying decimals. Yeah, I did at the end. But everyone like cracking on. Yeah, we'll go with it. We'll go with it. So if I just go back. Right. So bus stop method probably hasn't changed drastically. 471 and then 3. Okay, so we put our 471 in our bus stop, and we are dividing by 3, so that comes outside of it. The first thing we need to do is look at how many times 3 will go into 4. Now, it will go in once with 1 remaining. Okay, so it goes in once, so I'm going to put 1 on top, and my 1 that's remaining is going to go there and make this into 17. Now, my next step then was to see how many times 3 will go into 17. Now, sometimes it might be easier for children to write it down the side of their page, just so that the 3 times table, just so they can see it there and it's nice and easy for them. And I'd definitely recommend that with long division, but with this is generally not so bad. So I know that then 3 times 5 is 15, and I can't do 3 times 6 because that'd be 18, it'd be too much. So because it's times by 5, I'm going to put my 5 on top here. And I said I've got 2 remaining, so I'm going to have to put my 2 there. So that's how many remaining from the last one. And then 3, how many lots of 3 are going to go into 21 then? 3 into 21 is 7 times. So I'm just going to pop that there. Okay, and then I've just got my answer sitting on top of my bus stop because I've worked out how many times or how many lots of 3 will go into each set of number as I move along, and the remainders carry with me. Now, if, for example, I got to the end and it was 22, what I could do is either just say that there is remainder 1, and I just write that as R1, or I can carry on and put in decimal points. So I can put in a decimal point and a 0, decimal point and a 0, and I carry that 1 over there and see how many times 3 went into 10, etc., etc. And you can carry on and try and find out the decimal places. Obviously, this was nice because it all linked up. Oh, I just got rid of my bus stop. All linked up into 1. Let's just check the chat again. Yeah, fine. Right. Next, okay, long division. This, for me, as a child, was a nightmare. I'm not going to lie, I hated it. I hated every second. My dad was fuming when I didn't get it because he was like, how can you not get it? It's simple, look at it. But there are 2 different ways. And I think when I was younger, I was taught the formal method, and the chunking method for me just works because it's a little bit more visual, I think. But like I say, I will probably teach both of these in the classroom because it gives the option. And I think that's really important. I'd rather that, because for some children it'll be like, oh yeah, the formal methods are really easy. Don't get the chunking one, and then for others they'll love the chunking and hate the formal. So just whatever works, really, whatever works for different people. So you can see I've used the same question just to show the different steps, because it can get confusing, and there are remainders with this as well. So with this question. So, right, I am going to write it out as the bus stop anyway, just because in my head that just shows me that I'm doing division. I'll put my 16, my bus stop, 4, 2, 7. Now, starting off with chunking. Chunking just means that we are taking away different amounts of 16 at a time from our number. So I'm going to start off, because I know I can take a big chunk out of it. So 16 times 10 is 160. So I'm going to take 160 away from 427. Now, put 160 there, and now it's a subtraction formula. So there, you can do 7 take away 0, which is 7. 2 take away 6 doesn't work. 3 there, that's a 3. And then I'm going to carry my 1 back over. 6, and then 3 take away 1 is 2. Okay, so that's where I'm left now. Perfect. On the side, I'm going to write times 10. Okay. This is where it's going to show me on the side as to how many lots of 16 are going into my original number. So at the moment, I've got 10 lots of 16 going into 427. I'm not done yet. Now, what I'm going to do is I'm just going to take another 160 away from 267. Just nice and simple, not trying to break the bank with it. This is what the chunking method's about. So again, 7 take away 0 is 7, 6 take away 6 is 0, and 2 take away 1 is 1. So leave that in there. Now again, I need to write on the side, really important, because otherwise I've lost track of how many I'm taking, how many lots of 16 I've got, is another 10 lots of 16. Now, if 10 lots of 16 is 160, like I've got over here, 16 times by 5 is going to equal 80. Perfect. So looking at that now, that is less than 107, which is my next number. So I'm going to try and take the next bit. So I'm going to do 80. I'm going to do 107, take away 80. I'm going to need to move this up my page. Not like that. Right, so again, 7, take away 0, 7. Can't do 0, take away 8. And I carry that 1 over. So 10 take away 8 is 27. Now you can already see just how important not only times table knowledge is, but also the ability to subtract accurately is when doing these. So there I took was another 5 lots of 16 that I'm just going to write again down on the side. Lastly, I can't do 2 lots of 16 here because I've only got 27 left. I'm going to do 1 lot of 16, subtract that. So 7 take away 6 is 1, 2 take away 1 is 1 as well. Now I'm left with 11. I can't take 16 away again. Okay, so that is going to end up being my remainder. So I try and grab that down again. What I'm left with, yes. What I'm left with now is that I know that there were 10 lots here, 10 lots here, 5 lots there, and 1 lot at the end that we constantly kept chunking and taking away from 427 until we couldn't do any more. So now I just need to add these up. So I've got 26 there, but I need to remember that I also had this at the end. So it's 26, remainder 11. Now, I quite like that method because I can quite clearly see what I've got left to do as I go along. But then, you know, some people who aren't as confident with their subtraction or their multiplication, doesn't work for them quite so well. So it's purely preference as to what we are doing. I learned bus-stop method in a different way at school. Numbers line up below each other. I've always, sorry, Mr. Dick, I've always done my method that way for bus stop method, and I've put that in the online videos as well. I don't know if it's high school method. I don't know if it's just a different method. I think just the way that, like I say, it's that consistency between home and school, isn't it? But it's good to know that that is a different way that, you know, that it can be done or might be done at home. So when I teach it, I will do it in the way that I've just shown you, so, if that makes sense. But yeah, right. So that is my nice long page of long division, the chunking method. So next, then I'm going to go on to the formal method. Right. So again, because I'm doing my divisions just in my head, I just like to have it there in my bus stop. It just shows me what I'm supposed to be doing. 4, 2, 7. Now, slightly different. Here, for formal long division, I would definitely have my times tables written down the side as to what I am dividing by. So I'm going to have 16 to 48, 64, 80, and so you can, yeah, let's just go for another one, 96. Okay. So I'll have that there just so I can refer back to when I'm going along now. Right, first step, I need to see how many lots of 16 will go into 4. Okay, doesn't work. It's not a thing. So now it's a case of how many lots of 16 will go into 42. That will work. I can't do 48 because it's too big, so it's going to have to be 32. So I'm going to write my 32 directly under those two numbers there. It's then a subtraction. So I'm going to subtract next. And it's going to be 2 take away 2, which is 0, and 4 take away 3, which is 1. So I'm left with 10. Fine. Not an issue at all. My next step is that I am going to pull this number up here down to join in with the party. So at the moment, the 7's sitting there by itself. It's not up to much. So I'm going to drag him down and plop him there. So 7 is going to come in there for me. We've now made 107, which is a number that we actually had in our chunking method as well. And now we just need to go back to the drawing board on here and see what number we can take away, but as being the closest that we can. So that's going to be 96, because if I added another 16 on, it would be more than 107. So under here now, again, lining up my digits, I'm going to have 96, that's subtraction, pop it there like that. So 7 take away 6 is 1. I can't do 0 take away 9, so I'm going to get rid of that and put the 0 there, put the 1 there, and 10 take away 9 is 1 as well. Sorry, what I should have done, it's my fault now. Here, when I did 32, okay, because that's 2 times 16, I should have put the 2 above there like that. And then when we did 96, that is 1, 2, 3, 4, 5, 6 times 16. So I should have put the 6 up there like that. Okay, and now again, I'm left with my remainder of 11 at the bottom, which I'm going to write in there. So you can see from both methods, we've got the same answer. Let's go back. Same answer, just very different ways of doing it. It's just remembering on here where you've got to bring the number down. You've got to probably write down your numbers down the side down here. But like I say, it's very much up to you as to what you'd like. Yeah, lost on this one. Absolutely. I think I am also trying to rattle through this as well. But it's the different steps with this one and making sure that you're subtracting at the same time and writing things and bringing numbers down from different places. I don't know. That's why I think the chunking is just a little bit more visual. But like I said, I will pop that. But in fact, this is the only video online video I haven't done yet, is the long division. But we'll definitely do it because it's probably one of the most important, as it's just one of those ones that really splits opinions. So yes, right, finally, and then I will let you get on with your evenings rather than listening to me drone on about maths. Multiplying decimals looks horrible, always looks horrible. It's not as bad as it looks, because what we're going to do is we're going to line up the numbers 33.1, and we're timesing it by 4.2. Now, the first thing I'm going to do is scrap those little things in there. Get rid of the decimal points. We don't want them. And we will come back to that later on. So then all we've got is a normal multiplication. So I've got 2 multiplied by 1, and then you can choose the way that you would like to do this. 2 multiplied by 1 is 2. 2 multiplied by 3 is 6. And then I've got 4. But also, obviously, remember it's 10 times bigger, so I'm going to need the 0 in there. 4 multiplied by 1 is 4, and 4 multiplied by 3 is 12. So I'm left with that. Add those two together. So put that there. 6 add 4, 0, carry my 1. Then I've got 2, but that's the 1, 3, and my 1 on the end. So now my answer is 1,302. However, that can't be right because our question was 3.1 times by 4.2. So what we're going to do is we are going to go back to our original question. We're going to count how many numbers there were after the decimal points in the question. So in the question, there was 2 numbers that came after decimal points. That means that in our answer, we also need to have 2 numbers that come after the decimal point. So I've got 1, 2, they both need to come after the decimal point. Therefore, my decimal point is going to go there, and my answer is 13.02. Okay, so multiplying decimals, not as tricky as it seems. You literally just have to take away the decimal point and then pop it back in afterwards. There you go. So yeah, lots of different opinions on the different methods, the chunking and the formal method for long division as well. It's just a little bit different. Like you've got, like I say, different opinions in the chat. Honestly, if you need to rush, need to go, please don't. Brain hurts. Yeah. Numbers for a Monday evening, isn't there? Honestly, I was recording the videos, the ones I'm going to put online the other day. I was here till 8:30, and I think the caretaker was about to kill me, and my brain was absolutely fried. But yeah, so hopefully that's been relatively useful. I don't know, maybe it hasn't been useful at all. This is about trial and error, just seeing what parents are happy with, what they'd like to engage with, what works, what doesn't work. And you know, if you've joined, I really appreciate it, because it's not only helpful to the school, because so my dissertation was built around school improvement, really beneficial to the school, but obviously also ending up being helpful to myself as well. I don't know if there are any other questions. You know, if you want me to even just do like extra examples or anything, I've recorded the videos and they will go online, but I can obviously add more examples to those as well, or send home any sort of like written examples or whatever you would like me to do, just so that helps you to understand when we do send more homework home as well. So yeah, we're on 47 minutes now, which isn't too bad considering the technical hitch at the start. We're sort of hoping that it'd be around there. Yeah, I mean, it's, hopefully nice to. I wish I was able to see you. I think I said that in the email this morning. I wish that it was set up so that I was able to see you guys as well, to actually get reaction. I wish we could have done it in school, but hey, and yeah, you know, if any other questions, anything at all that you ever want to ask, please do. I'd much rather that than, you know, you be left stranded or child be left stranded. Yeah, so written examples I can definitely do. Other resources. Yeah, so when I post, I will get onto Mr. Jones tomorrow, because he's got the access to YouTube, which is what I need to post it onto to then put it on the website. I will put examples, the videos that I've done on the website, which are exactly the same as those. I've just recorded myself again on the board, doing the examples, and the PowerPoint as well, which I've changed to a PDF just so that the other schools don't steal everything that I've done. All sorts of rivalries. No, but so I'll put that on there as well, and they're all examples that I've done, or the examples of how we do it in school. So yes, so when there are new maths concepts taught in class, it'd be really helpful. Short video up on Twitter. Yeah, okay, like that. So yeah, I can definitely put something on Twitter. Yeah, but please don't mention another homeschooling. We definitely don't need that. We really don't need that. But yeah, like, you know, if it was to happen, then yes, all of these will be on there as walkthroughs, so that they are able to crack on. So yeah, hopefully I get to. Well, I think we've got parents' evening will be towards the end of October at some point. I don't know if you've been told about that. If not, sneaky piece of information. Yeah, towards the end of October at some point. So I will meet you all then. But again, thank you for making the effort on a Monday evening. It's not prime time, but yes, I really appreciate it. So thank you very much. And any questions, drop me an email. Written examples I can definitely do, not a problem at all. In fact, I can get on that now. But yes, thank you very much, and I will hopefully see you soon. Yeah, perfect. Thank you.